We're back again for the 7th. This is the last chemical reaction in the Chemical and Physical Changes Lab. And in front of me, I have a beaker of what's called deionized water. Now, deionized water, got a fancy name, but water is water in a sense. When water comes out of the tap, even though we know that it's called fresh water means it's not too salty. It doesn't mean there's no salt in it. In fact, the water we have, of course, has salt in it. There's almost no pure water in the world. Only in chemistry labs is there pure water. All water has a little bit of salt dissolved into it. It depends on where you are. There's different kinds of salts that are dissolved in the water. And that's why some water tastes good and some water tastes bad. Where I'm from in New York City, the water tastes really good. Up here, you get used to it. It's not as good. And you know, it's like kind of like Hershey's chocolate kisses or M&M's. They're both chocolate, but they taste a little different. There's no official best water. It's a qualitative measure. But New York City water's got slightly different salts, different amounts of different salts, gives it a certain flavor. Tap water has salts in it too. Our tap water is a little different than New York City and different than San Francisco. Different parts of the world have different salts. Deionized water, we have a special filter. And this filter, as we run the water through the filter, is able to remove all the salt. So this water is about 99.9% no salt ions at all. All of them have been removed. So in our school, this water, which looks just like water everywhere else, has no taste. Okay, I've tasted it, but you can't. And it's mostly, almost all H2O only. So what you call water and what is water, two totally different things. This is deionized water, and I have a thermometer in it. And the thermometer for this tap water, I'm reading it pretty well. It says 20.7 degrees centigrade. I'm going to write that down because you are too. 20.7 degrees centigrade. The thermometers have lines for each degree, which means you must read it as accurately as possible to the 10th degree, because I can see to the closest degree. And my eyes see that it's between 20 and 21. It's more than halfway, but it's not really close to 21. So I see it to the best of my ability at 20.7 degrees centigrade. I got this really cool stuff here. Can you see it? Potassium nitrate. This is another white powder, but you know what? Don't get this one in your mouth. I tell everybody, this one gets in your mouth, you're not going to make it to the bathroom in time. It's going to be really embarrassing. This is not food. Not all salts are good. Not all salts are even safe. This is a salt because it's made of a metal and a non-metal. That's what a salt is. Sodium chloride that you eat, or calcium chloride that you put on your sidewalk that you could also eat. You shouldn't because it's gross. It's not food grade. I've tasted it, so I'm a chemistry teacher. The stuff you put in your water softener, also calcium chloride, a little bit cleaner than the rock salt. There's different salts. Sea salt's got a bunch of different salts in it too. I'm going to put some of this in there. Now, I'm going to make some salty water. Salty water just means salt dissolved in water, and it's completely mixed, homogeneous. It's an aqueous solution, the same throughout. But we're going to watch what happens to this thermometer. So first, I'm going to put a good amount of this in because we're not using too much this year. We're just going to put it in there, and I'm going to watch. I'm going to give it a little stir. Stir this up. We're going to give it a minute. And you know what I'm going to do while we're waiting for something to happen? I'm going to pick this up. Remember we did this before? We did this chemical reaction. This was the second one, the cobalt chloride and the lithium carbonate. And it's harder to see, but again, clear on the top, darker on the bottom, because it's settling out. This is not just a color change. It's a color change caused by a precipitate, and the precipitate is falling to the bottom. And I've got this in another beaker kind of sitting on its side so we get a little settled. But let's see if I can hold that up. Can you see that it's a little more clear on the top and a little more particulate at the bottom? Over time, this will completely settle out and it will be clear on the top and dark on the bottom. So let me stir this up and let me get a quick check of the temperature. And the temperature, well, let's give it a little stir because maybe another minute, another 30 seconds. I'm going to stall now. The temperature is down to 17.9. And if you do your math quick, that's 2.8 degrees that it's dropped in temperature. 2.8 degrees. Now, I'm in a room. This This salt, potassium nitrate, it's room temperature. The tap water's been, I poured that a half hour ago. It's been sitting over here with the thermometer. The water's at room temperature too. But when I put these two things together, the temperature dropped by almost 3 degrees, 2.8 degrees already. Yeah, we'll give it another check. We'll see if it goes down even more. Woo, it's cold. It feels so cold. It actually looks like 17.5. It's actually down more than 3 degrees centigrade in just a couple of minutes. T in topic B is temperature change. Now, the most important thing right now, this is a trick. You got to pay attention. What did I do? I put a powdered salt into water, stirred it up, temperature dropped. Temperature change, that's an indication that a chemical reaction probably has occurred. Doesn't mean it had to occur, it means it probably occurred. You have to think about this. What if I put sodium chloride in that water? Table salt. You could do this at home. Put some table salt in, stir it all up. There'll be a temperature change. You can't register it, it's too small. This stuff, I happen to know, makes a big temperature change. Most salts don't make big temperature changes, but some of them make even bigger ones than this, but this is safe, mostly. And it makes a temperature change. And in ChemLab, I got to give you some tricks so you can think about it. Oh, wow, that was pretty cool. When you put salt in water and you make a mixture called a solution, a homogeneous solution, the same throughout, what if I said, how do we get that back apart? Well, you could sit it around for a couple of days and the water will evaporate away, or we could boil it and the water would boil away, but the salt would take thousands of degrees centigrade to boil. So the salt would just get hot. In a little while, the water would boil away and we had the white crust still at the bottom of the beaker. It's not making a new substance with new properties. Actually, it's forming a mixture. And this particular mixture that forms happens to absorb some energy when it does it. So there's a temperature change. Some other salts go in and make it really hot. Temperature change. But it's just a solution. We're not making something new with new properties. We're making a solution. We're mixing the salt and the water together. It forms a homogeneous mixture called a solution or an aqueous solution. It's dissolved in water. But it's not something new. It's still the salt and it's still the water, and we can get them apart by patience and evaporation or haste and vaporization. Right? Comes apart. Physical, take advantage of a difference in physical properties. Take advantage of a difference in evaporation, or take advantage of a difference in boiling point. This is not a chemical reaction, even though there's a temperature change. Topic B are the indicators that a chemical reaction probably happened, and you got to start paying attention. Doesn't mean for sure, hands down. So this is a really cool thing. I'm going to wipe this up and see you soon.